Hi everybody, welcome to Unit 6, Lesson 4, Pythagorean Theorem Proofs, right? Now we're getting into the really big stuff. So there's a lot of vocab, as always, in geometry, but two of the most important ones right now are proof, a logical sequence of steps used to prove a theorem from other known facts, okay? And that is so much of what geometry is based on, so that's a really important thing to know. And then Pythagorean theorem, which is a theorem that states if a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. Holy moly. That sounds crazy, right? But it's based off of this picture here. Okay, so I have a right triangle. Remember, a triangle is a right triangle if it has a 90-degree angle, all right, also known as a right angle. I'll go ahead and put that in there, 90 degrees, okay? The two sides of the triangle that make up that right angle are known as the legs of the triangle, okay? And usually they are known as A and B. And then the side that's opposite, the side that like the right angle is looking at, is known as the hypotenuse, okay? It's also always the longest side in a right triangle, all right? And so if we go back to this definition, a theorem that states, right, this is a theorem, states if a triangle is a right triangle, then the sum of the squares, so sum of the squares of the legs, right, A and B were the legs, is equal to the square of the hypotenuse, or C. Okay, so that's what that's coming from, right? Your lesson does a good job of proving why this is always true. They go through the proof. I'm not going to do that right now, but your lesson does that for you. So I've got 3 examples for us. Number 1, we've got this triangle. Okay, it says build the Pythagorean theorem based off this triangle. Okay, so remember the Pythagorean theorem, right? It looked like this. A squared plus B squared equals C squared. You've probably heard that before, okay? Where these are the legs and this is the hypotenuse. Well, over here in this triangle, these are the legs and this is the hypotenuse. So to build it based off of this triangle, I would say P, the lowercase p, squared plus S squared equals T squared. That's what that would look like. We could technically like flip-flop these. These are all the lowercase ones, by the way. They labeled the angles with capital letters, but I'm trying to write them as lowercase. My S doesn't really look like it, but that's what I was meaning to do. Okay, so that would be the Pythagorean theorem based off of that triangle. Number 2, triangle GHI is a right triangle, and you always name a triangle based off of like the angles. Okay, that's what it's naming it as. One leg is length 11. The hypotenuse is 22. What is the length of the other leg? So we could draw this out, but we don't really need to because we know the Pythagorean theorem. We know A squared plus B squared equals C squared. Well, I know one of the legs is 11, so I could say 11 squared plus B squared, and then my hypotenuse is 22. This is where you get to use your handy dandy calculator. Okay, so make sure it's on scientific mode, all right, because we're going to need our square root, okay, or you could use your square as well. Oops, let me clear it. Okay, so here's my calculator. Trying to make sure I have room for everything. There. That's a little better. Okay, so over here I've got 11 squared. I could do 11 times 11, right? I know that that's what 11 squared is equal to. I could even like write all that out. I could say 11 times 11 plus B squared equals 22 times 22 if I wanted, and then 11 times 11 is 121 plus B squared, and then I've got 22 times 22 is 484. Well, I'm working towards getting B by itself. I'm looking for that other leg length. So I need to get rid of some stuff. I need to get rid of this 121. I'm going to run out of room. So these cancel. I'm left with B squared equals, and then let's see, I've still got my 484. So I'm going to take away the 121, which gives me 363. Well, to cancel out a square root, or I'm sorry, in order to cancel out a square, you need to square root it. Those are the opposites of each other. Like here, I was adding 121, so to get rid of it, I need to subtract 121. I did the opposite operation. So the opposite of a square is a square root. So I'm going to square root both sides, and what that means is these will cancel out, and I'll be left with just B. Okay, and then on my calculator, I need to do the square root of 363, which gives me 19 point blah, 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 right? It's not a perfect square. Now, in your in your practice, it asks you to round to the nearest 2 decimal places. So that would be right here, 2 decimal, that's the hundredths place, okay? So I'd look to the right of it, I'd look at this 2, since it's 4 or less, the 5 stays the same. So the final answer would be 19 5/100. Okay, you could say units, because we don't know whether it's inches or centimeters or anything like that. So that would be your final answer. That's number 5 from your practice, also, just so you know. Okay, number 3, and I'm worried I didn't give myself enough room on here either. We'll find out. This is number 3 from your quick check. Use the converse of the Pythagorean theorem to tell whether a triangle with sides 15, 10, and 12 is a right triangle. Sorry, I did not write that very well. I don't know what happened. And why not? Okay, and why not? So I'm going to tell you right now, it is not a right triangle because, so let's set up, we've got our Pythagorean theorem, right? We've got a squared plus b squared equals c squared. Well, the longest side is always your hypotenuse, so we could say 15 squared. And then we've got 10 and 12. It doesn't really matter which order we put them in because we end up adding them together, and when you add it, the order doesn't matter, right? Because of the commutative property. So let's go ahead and see, are these equal to each other? Well, 10 squared, that's like 10 times 10, or 100. And then 12 squared is 12 times 12, or 144. And then 15 squared, maybe you have it memorized. I don't, and my brain is not working very well right now. So you can just do 15 times 15. Gives me 225. I should have known that one, but that's okay. Somewhere in my brain I did. Okay, so I'm going to rewrite this up here because I ran out of room. So I have 100 plus 144 equals 225. Well, 100 plus 144 is 244. Okay, so with that, 244 does not equal 225, so it is not a right triangle. Because of that, because we couldn't add the squares of the legs to equal the square of the hypotenuse, okay? Because I didn't get the same answer on both sides, it's not a right triangle, okay? So when it comes to your quick check, and I'm sorry, my dog thinks she's real tough right now, that would be your reasoning, would be that these are not equal, okay? So I hope that helps, and reach out if you need more.